Hello everyone, in this video I'm going to go through question 2 of the mock exam on analytical geometry. So once again, I'm not going to go through all the information again since I went through that in the first video. Let's start with question 2.1. Calculate the gradient of BD. So BD, straightforward question, we can see our 2 points. And so all it's about is substituting into our line. So remember, beginning of your question, write down question 2 and underline it so that it stands out for the examiners so they know where your question 2 is, and number your questions correctly. So small m, so you know it's your gradient, is going to be, so point B is -14, -10, my x value under my y value, and we need the change, so we're going to subtract. And point D is -8 and -4, the x value and the y value. And here's the easy part, you put it into your calculator and you get a value of 1 for your gradient here. Straightforward, easy question. 1.2. Hence, so we've got to use our gradient from here, write down the gradient of AC. Now, AC over here, we might not immediately see, but BD is down here. But if that line continues up to E, they are 90 degrees to each other. So we know that we can use the gradient of the first line times by the second should give us -1. So that is pretty straightforward. In fact, hopefully you can say, well, 1 times what must give me -1. And so my gradient of AC must be equal to -1 if I'm going to multiply to get 1. And I would advise you to put in those line names next to your gradient just in case you need to come back and use them. 2.3. Determine the equation of AC in the form y is equal to mx plus c. Now you can use this format and substitute into it, or you can still use your other formula. You can still use the y minus y1 is equal to my gradient. Now we already have our gradient from the previous question, so I'm going to substitute that straight in. And that should be x, not y, x minus x1. And so to simplify this, we need a point on that line. So now I go back to my picture. I'm looking at line AC. We don't know the coordinates of C. We don't know the coordinates of E. But A we know the coordinates of, and we can substitute that in for x and y. So our y value for point A is -1, and our x value for point A is 4. And don't forget, they asked us to write it in the form y is equal to, so we need to solve for y. So y plus 1 is equal to, I'm going to distribute my -1, that gives me -x plus 4. To get y on its own, I'm going to subtract 1 from both sides, leaving me with -x plus 3 as my final equation. Moving on to 2.4. 2.4, the point G lies on AB, calculate the value of P. And as we said, we're going to use collinear points where we know that our gradients are equal. So in the memo, I showed you one method. In the video, I'm going to show you another method. So I would look for the 2 points that I know coordinates of on that line, so A and B, and I would work out their gradient. So the gradient of AB will be, point A is 4, -1, and point B is -14, -10. And I would put that into my calculator, and I would push equals, and that will give you 1/2. simplified fraction. Now we know that 1 over 2 will be equal to the gradient of g with either a or b, and you can choose either point to put with g, but you need to make sure that you use g so that you have your variable p in your equation. So starting with point p so that I don't forget about it, it's p and -5 and my change, and let's go with point b. That's going to be -14 and -10. Right. My next step here is I would simplify so that I don't have all sorts of brackets in there. So 1 over 2 is equal to -5 plus 10 will give me 5 all over p plus 14. And so we can see we've got two LCDs, and so to get rid of our LCDs, we're going to multiply by them. So we will have p plus 14 times by 1, which gives me p plus 14. And my other LCD is 2, so I times by 2, which gives me 10. And then we're going to subtract 14 from both sides to work out p on its own, which gives me an answer of -4. And there is the value of p. And now for our final question, 2.5, calculate the coordinates of C. So I look at C, it's a vertex in my triangle, but I know nothing special about this triangle, so I can't use distance or midpoint to work out point C. But at the beginning, they gave us this equation for line CB. And since we've got that equation, I'm going to say, well, can't I work out the equation for AC? And if you remember, here in question 2.3, they asked us to work out that equation, which was y is equal to -x plus 3. And if I've got the equation of those two lines, I can work out point C, because C is where these two lines intersect. And so we're going to use simultaneous equations to work out our point C. I would start by writing down the equation of each line. So BC is 4y minus 5x minus 30 is equal to 0. And before you carry on, just do a double check to make sure you wrote it down correctly. AC, unfortunately, we will have to do method marking if you got this one incorrect, but that's okay. Work with what you've got. Right, y is equal to -x plus 3. And simultaneous equations, we want to make this one equation where we're working with only one variable. And nicely you can see y is already equal to this expression, so I can replace y with -x plus 3. So over here, instead of 4, I'm going to put -x plus 3 in my brackets, minus 5x minus 30 is equal to 0. And just to remind myself what I did. Okay, and now we're going to solve for x. So I'm going to distribute 4, which gives me -4x plus 12 minus 5x minus 30 is equal to 0. Now I need to combine like terms. So -4x, -5x is going to give me -9, but I like working with positive x's. So I'm going to bring that over to here and have positive 9x. Positive 12 minus 30 is going to give me -18. And if your arithmetic isn't that great, just quickly type it into your calculator. And then to get x on its own, divide both sides by 9. You can see I'm in a good habit of showing that working out. And so x is equal to -2. But we need the coordinates of C. So I'm going to take that x value and substitute it back into this equation, since it's simpler and it's already got y is equal to. So instead of x, I'm going to put -2 and plus 3. So that's going to be positive 2 plus 3, which gives me 5. And because they've asked us to calculate the coordinates of C, I would go one step and say C is, my x value is -2 and my y value is 5. Now I know in this question they didn't assign marks to your C value, but generally if they've asked for coordinates, there is very likely going to be a mark for writing that point as a coordinate. And to show my teachers that I am done, I'm going to rule a line at the end of the question.